Stan Gibilisco here to describe for you a simple type of laser design known as a cavity laser. A cavity laser because it resonates within a cavity or medium of certain dimensions so that it reinforces the light waves as they bounce back and forth between these reflectors. One of them is like a mirror at one end, at the back end, and the other one lets 5% of the light through, so most of it gets reflected back, and the light reflects back and forth and back and forth and back and forth, reinforcing itself because there's a certain resonant frequency at which these waves tend to go over themselves repetitively in the same phase with every reflection. That produces resonance very much like that in a radio antenna. And eventually, the cavity develops light so intense that it bursts through this 95% reflector and produces coherent light. Coherent meaning all of the light energy is at a single frequency, and therefore you get effects peculiar to lasers, such as the ability to be concentrated into a very narrow beam, the ability to propagate for long distances. As for burning holes in pieces of metal and things like that, those are much more powerful lasers, generally speaking, than this. This is the type of laser you might use for optical communications or infrared communications. But the basic principle is that this cavity or enclosure, which can take either of two geometric forms, shaped like a rectangle looked at cross-section wise, or a cylinder with flat ends, or a cylinder with slanted ends and reflectors that are slightly concave. Either way, you get the maximum radiation coming off towards the right in these diagrams through the 95% reflector. And this wave just continues to reinforce itself because the dimensions of this device are such that the waves bounce back and forth and reinforce each other in phase. Just like I said, just like they do in, say, a half-wave dipole radio antenna. So that is the simplest, one of the simplest types of lasers known. As for what this cavity is actually made out of, it can be made out of a number of transparent solid substances such as ruby, and ruby laser is a very common type of laser. But laser actually stands for light amplification by stimulated emission of radiation, and can be theoretically done at any frequency, but most commonly at infrared invisible light. So those are just two very similar designs along the same basic concept of the cavity that resonates visible light waves inside of itself and produces this so-called coherent light, where all of the energy is concentrated at a single wavelength, producing a narrow beam of high intensity light. You can buy some of these types of lasers at hobby shops, or at least you could when I was in high school 40 years ago. It was called Edmund Scientific. Anyway, you can find them, and you can maybe even build one of your own if you're so predisposed. Basic laser design of the simplest type. Stan Gibilisco signing off. Until next time, so long.